I hope that this is big enough that you guys can kind of see it pretty clearly. I'm just really going to fill in the blanks for you on this, and we're going to talk about the standard form of a quadratic equation, and we're kind of moving into this unit on quadratics in general. And quadratics, I don't know if you remember when we were doing the parent function. The parent function of the quadratic was just x squared, and it kind of follows that any like lead off uh, if your highest power is a square, it's going to be a quadratic equation. Um, and they are kind of the fundamental part of dealing with algebra. We hit it in the end of algebra 1, and it's a big part of algebra 2 is dealing with quadratics. Um, the standard form for a quadratic equation is f of x equals x, whoops, I'm already screwing it up, equals ax squared plus bx plus c. Now, A, B, and C are really important pieces of information in this because everything we do, like in how to find things, is going to relate to those A, B, and C. And A is always that coefficient, that number that's in front of x squared. B will always be in that x position, right? Whatever we're multiplying times x. And C is just any number that doesn't have an x value, right? It's just what we call a constant. So we're talking about coefficients and constants when we talk about A, B, and C, and um, and the reason I'm telling you that is because it's going to play a part in what these graphs of these functions is going to look like. So this next part, it says use your graphing calculator to sketch the following functions, and I'm not going to do that because I do not have a graphing calculator on me right now. I'm going to give you a general idea of what the graphs of these functions look like, because the more important part is that what we're trying to show is that if your a value is positive, that number in front of x squared right here, if it's positive, your graph is going to open up. And if it's negative, your graph is going to open down. And if you look at these functions in the little box where it says example, it says right here, notice that what is in front of our x squared is nothing. And so that just means it's 1, right? On this side, it's negative, which just means it's -1. And what that tells me is this is -5, so it's going to be kind of down here somewhere on the graph. And I'm going to have a U shape because they always are U-shaped somewhat, that points up. And that's the only thing I'm really trying to show you at this piece right here when we're doing the graph. This piece has the negative in it and +7, so it's probably going to be up here somewhere, and it's going to be a U shape that goes down. Now, pretend that's a U shape. It was really poorly drawn, but I think you get the general idea of what we're looking at with that, right? So you can always tell if you have a positive or a negative. You can look at the equation of any quadratic and know if it's going to be up or down just by what's in front of that x squared. If it's positive, up. If it's negative, it's going to point down. The next thing we're talking about are the parts of the parabola, and the parabola is what we call that U shape. And it says here that the vertical line that divides the parabola into 2 equal parts is called the axis of symmetry. Now, if you look at a parabola, just like when we were talking about absolute value, we have a turning point in that, right? There is a vertex where this U is going to turn. right? This one, it's going to be like boom, 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 boom. You can kind of cut this right down the middle, right? And what they're saying is that line that divides it down the middle is what we call an axis of symmetry, because everything that's happening on one side of that line is also reflected on the other side of that line. It's like you can take a piece of paper with a parabola drawn on it, and if you fold it on that axis of symmetry, they would line up together, right? They would overlap. And that's what your axis of symmetry is. And it provides us a lot of information to know what that axis of symmetry is, because it helps us find our vertex, right? And if you remember when we were graphing those absolute value functions, that vertex was really important for us as to know where to kind of start putting in x values. So the formula for finding your axis of symmetry and also the x value of your vertex is x equals minus b over 2a. Ooh, over 2a. And where we get those b's and a's comes straight out of this equation. B is whatever is the coefficient in front of our x value, and a is whatever the coefficient is in front of our x squared. So then it goes on to tell us what we've already talked about, which is that the turning point of the parabola is called the vertex, right? And when the vertex is the lowest point, which means if the parabola is opening up, your vertex is a minimum. It's the lowest point on the graph. If your parabola is going down, if it's negative, your vertex would be the maximum or the highest point on the graph. So it says to label this on the graphs above, but my graphs suck. But we can go ahead and do that, right? This down here would be our minimum, right? This up here would be our maximum. Does that make some sense? Those are our vertex points. Those are our turning points. What the axis of symmetry gives us is the x value of that vertex. And then when we take that x value, we can plug it in and find our y value. So let's look at this in terms of finding just the axis of symmetry and the vertex of the problems that we have down here. First of all, right off the bat, I can look at this function, right? I have 4x squared. That's it. If I look at the standard function says f of x equals ax squared plus bx plus c. But the only thing I'm required to have is that x squared for it to be a quadratic. So our b would just be 0. Our c would just be 0 in this context. Does that make some sense? I'm looking for the few faces that I can actually see on this screen to feel like, thank you, Walter. So in this case, all we have to do, first it's asking us for the minimum and maximum, right? Well, as long as whatever is in front of my x squared is positive, it's going to be a minimum. Because think about that, my graph's going to go up, so it's going to be our lowest point when it's positive. So we already know it's going to be the minimum. And we have this formula for the axis of symmetry, right? To find the axis of symmetry, which is minus b over 2a. But in this case, our b is just 0 because it doesn't exist, right? All we have is that x squared. So I have minus 0 over 2 times a. Well, a is just 1. So we do that, but it doesn't matter because as long as we're dividing into 0, that just means our axis of symmetry is at 0, right? So our axis of symmetry, I don't know how they were listing it up here. I would just say x equals 0. And that is that line that divides down the middle of our parabola of that U, right, shape that we make. Now it also asks us for the vertex. And the vertex is really easy to find because once you have the x value, you already know that the x part of the vertex is 0. And you find the y part by plugging 0 in for x. So here I would have 4 times 0 squared. And in this case, well, 0 squared is 0, and then 0 times 4 is also 0. So our vertex is at the origin, right, where x and y come together. If we look at number 2, we have a negative in front of that x squared, right, which means that it's going to be a maximum that we're dealing with. The axis of symmetry, well, we're going to do our minus b over 2a formula. And in this case, that would be minus, our b is 6, right? We don't have a c, and our a is negative 1. So I'm going to say minus 6 over 2 times negative 1. And that's going to give me negative 6 over negative 2. And I only say it that way so that you can see that it comes out a positive. And so our axis of symmetry is at x equals 3, which means that the x value of our vertex is 3. And we have to find the y value by plugging in 3 for all our possible x's. So in this case, we would have minus 3 squared plus 6 times 3. And we would just solve that out. This is 9, but the negative on the outside makes it negative 9 plus 18 equals 9. Make some sense? I am going to take your silence as a yes. Yes, it does. Or that you're not paying attention. Let's just do one more of these and we'll move into the graphing one. I'm going to skip number 3 and move down into 4 because it's the first one that has all of the components. It's not going to really change anything in terms of how we're doing the problems right now, but it will when it comes to graphing of the problems. Here we know it's going to be positive, right? Which means that it's going to go up, which means that we are dealing with a minimum, right? Our vertex will be the minimum of this function. Our axis of symmetry is going to be our minus b over 2a, which for us, think about this, we have a minus 8 as our b. So that's like saying minus negative 8 over 2 times 1. And so when we solve that, that becomes 8 over 2, which just is 4. So our x equals 4. And then when we want to find our vertex, we're just going to plug it in. So I'm going to go, okay, here I have 4 squared minus 8 times 4 plus 9. That's going to give me 16 minus 32 plus 9 is 16 minus 32 is negative 16 plus 9 is negative 7. So this is negative 7. And so our point here would be 4, negative 7. And so that's how we're going to find our axis of symmetry, and it's going to be how we find our vertex. You're going to have to do it over and over again. Well, by over and over again, I think like 6 times. Um, but you're also going to have to graph all of these. And the best way to do it, well, right now, until we learn better ways to do it, is to use a table, plot the points of a table. And if we know what our vertex is, we can make that our middle point on the graph. So your first steps when you're graphing using tables is to find the vertex, the axis of symmetry, then that gives us the vertex. And then you're going to put it in the middle of your table, and then you're going to complete points around it. One great thing is your points are always going to be symmetric, just like when we had absolute values. So you know that like they're going to kind of repeat, those y values are going to repeat. Once you find half of them, the other half are going to fill themselves out, right? So what do I mean by that? Oh, and then we get to talk about the domain and the range. And on your worksheet, you will have to do all of those things, right? You will have to do the domain, you'll have to do the range, you'll have to do the maximum and the minimum, axis of symmetry, and vertex on your homework sheet. So this says graph each function and state the domain and range. And we can do that pretty easily, but we first need to find the vertex, right? We need to find the axis of symmetry and then the vertex. But if I look at this problem, right, my minus b over 2a, well, there is no b or c in this one, right? We just have minus 0 over 2 times negative 3. And we don't even have to do the math really on that because we know dividing into 0 is just going to give us 0. So we know our axis of symmetry is at 0, which means it's this y-axis, right? So we could say when x is 0, that's our axis of symmetry. And we're going to need to plug 0 into our equation to see what the y value is, which is clearly also going to be 0 because 0 squared again is 0. When we multiply it times negative 3, it's still 0 because no matter how many times we multiply it by 0, we're still going to get 0. And so we know that this value here is going to be 0 as well, which means that the points that we fill in around it, we can make less than 0 and more than 0. So I can make this negative 1, negative 2, negative 3, and we can make this 1, 2, and 3, right? And all we do is we plug those values into our equation to fill out the table. So I can do these in my head, and I don't have a lot of room to work. But if I were to plug negative 1 into this equation, negative 1 squared is just 1. 1 times negative 3 is negative 3. If I were to plug negative 2 in, well, negative 2 squared is 6, right? And 6 times negative 3, wait, sorry, negative 2 squared is not 6. I don't know where I'm coming up with that. Negative 2 squared is 4. 4 times negative 3 is negative 12. And I'm going to skip the 3 because I'm not even going to be able to fit this one on the chart, right, when I multiply times 3. And this is going to be the same thing. If you look at this, if I put 1 in, I still get 1. When I multiply it times negative 3, I get negative 3. And if you remember, just like with the quadratics, these are going to repeat, right? Now, I'm not going to draw a perfect graph on this. I know that my first point is here at 0, 0. My second point is at negative 1, negative 3. I know I have another point on this side, and my 2 is like all the way down here at 12. And then I can kind of pretend that that is a parabola because I suck at these drawing on this thing. But you get the general idea. Do your graphs have to be perfect? No. You do have to have your vertex in the right place. You should have two other points and kind of show that you know where that symmetry lies. And you do have to fill out the domain and the range. How did I get the other f of x points? I plugged in the values of x that I created around. So I found this axis of symmetry, right? So we know that that is like that turning point. And so for x, I just picked some points around it in each direction, right? I picked some in the negative direction and then some in the positive direction that were pretty close to it. And then I plug them into this equation right here for x. And so when I plug in -1, I have -3 times -1 squared. And whatever I get out is going to be my f of x for that number. So -1 squared is just 1. So this would equal -3. So at -1, we had a value of -3. Does that help? Yeah. And so whatever you get out when you plug it in is going to give you the y value. That f of x is really your y value, right? And it'll give you the other point. The cool thing is that if you keep your points the same distance away, like so our middle was 0, so I went 1 away from 0 in that direction, 2, 3, right? I kept it even. And if I do that on the other side coming down, if I go 1, 2, 3 on this side, I know that once I find the f of x's above it, they're going to repeat below it. So you don't have to plug in every single point. So let's do number 6. I'm not going to do all of these problems because I don't have time. But first I have to talk about the domain and the range. The domain of a function is always all of the possible x values that you can have. In the case of these parabolas, it is always going to be all real numbers, at least the kind that we're doing. So that's the sign for set of all real numbers. Or you could write it as -infinity to infinity, right? Because I can put in any value I want for x. Those arrows are always going to go in opposite directions forever and ever, right? To the left or to the right. For the range, though, the range is the possibility, all possible outputs, right? Which means that they are going to start at your minimum or maximum y value and either go on towards infinity or go on towards -infinity. So in this case, they point down. So I know that they're going to go on towards -infinity forever. And they are going to start at 0, right? Because y here equals 0. So I'm going to say that they go from -infinity all the way to 0, like that, with a bracket because it includes 0. Or potentially I could also say that y is less than or equal to 0. Both of those are accurate. You can choose how you do it. It won't be in delta math, so you don't have to do it a specific way. But I want you to understand that that's what's going on there, okay? Let's look at it. I'm going to skip number 6 and come down here to number 7. Maybe not. I'm trying to look at which ones. Yeah, let's do this one. It's positive. We know it's going to open up, but we do still need to find that axis of symmetry and the vertex of this problem, right? So we're going to do, for our axis of symmetry, we're going to do our minus b over 2a. And in this case, we have a b, which is -8. So we've got -8 over 2 times a, and our a is also just 2. So negative times -8 gives me a +8. 2 times 2 is 4, and 8 divided by 4 is 2. So we know our axis of symmetry is going to be at 2. So I'm going to place that in for my x value in the middle because I want all the points kind of going around that. And I know that the axis of symmetry will always give me the x value of my vertex, right? But I still need to figure out what the vertex is, right? Which means that I wish there was more, I'm going to just kind of write it over here just because I have room, but I'm not doing this problem. To find that vertex, I have to plug 2 in for x here, right? And that'll give me the vertex. So if I plug in 2, that's 2 times 2 squared. Oops, that's supposed to be minus. Minus 8 times 2 plus 6, right? And that is going to give me the y value, or that f of x. So 2 squared is 4. 4 times 2 is 8. Minus 8 times 2, which is minus 16, plus 6. That's like saying minus 10 plus 8. 8 minus 16 is minus 8. Minus 8 plus 6 is 2. I feel like we're in a time warp here because we're, oh, it's minus 2 though, isn't it? Yes, it is. So my turning point is at 2, negative 2. That axis of symmetry would be right up and down here. I want to pick points around it. So I'm going to put in 1 and 0. And then here I'm going to put in 3 and 4. And I just picked points around that axis of symmetry. And when I go to plug it in, I'm going to go up here because they're easier. Because I know that 1 squared is just 1, and 1 times 2 is 2. Minus 8 times 1 is just minus 8 plus 6, right? And that made my math so much easier. So 2 minus 8 is negative 2. I'm sorry, 2 minus 8 is negative 6 plus 6 is 0. And then if I were to plug 0 into this equation, this would become 0, right? 2 times 0 would be 0. This would become 0. And all I'd be left with is 6. And the cool thing is these points in the opposite direction I know are just going to be 0 and 6. Because they're symmetric, I know that, right? But if you don't know it, plug them in. Go ahead and plug them in. There's nothing wrong with that. So here at 1, I have a point at 0. Here at 0, I have a point at 1, 2, 3, 4, 5, 6. And on the other side, at 3, I have a point at 0. And at 4, I have a point at 6. And you can see our graph there. Now, on your worksheet, it's going to ask you, is it a minimum or a maximum? And in this case, it's a minimum, right? That vertex is our low point, so it would be a minimum. Our domain, again, all real numbers, doesn't stop. Set of all real numbers. It's like an R with an extra line, or you could write it negative infinity to infinity. Any way you guys want to do that is fine. Our range is what our y's can be, and you can see that right there, right? You can see that it starts here, can't go below that point, but it goes up for infinity, right? So we would say that our range goes from negative 2 to infinity, or we can just say that y is greater than or equal to negative 2. Does that make some sense to you guys? Does that feel like you can kind of grasp it? You have the video. You can watch these again. I will try and do different problems with my other class so that maybe I can post both videos and then you guys can have more examples. So when I do my class tomorrow, I'll do the sample problems from the other side that I didn't do for you, and it'll give you a little bit more to look at so you could go to either video. Um, and, tutoring will be open if you have any questions about it. Uh, I don't want to start another one because I feel like I don't really. Do I have time? 10:08. This class ends at 10:03. Um, you do have a piecewise function right here. I want to look and see if you have one of those actually in your homework. Um, I kind of want you to take a stab at it on your own and see how you do with it. But yeah, you do have a couple of piecewise functions on there. And I'm going to hold you to them. I'm not actually going to do them here. I would like you, I'll go over one in the next time we meet. I want you to take a shot at it on your own because we did do it with the a few sections ago. We worked on piecewise functions, and I just want to see where you guys are going to fall with that in the first place. So just give those your best shot. When I do your actual grade, I'm just going to check for completion on those to see that you gave it a try, even if they aren't right. So don't worry about those two problems too much in getting it right. I just want to see that you made an effort and gave it a shot, and we can always go back and go over them. Um, but there's too many pieces to them right now to get one done in class. And maybe if I have time later today, I'll just do a little video of solving a problem like that, or one of the ones from the notes, so that you guys have an actual like example that's not sitting through an entire class video, but just a problem solved video. I'm going to stop our recording now because I think we're